Page 15 in the review packet starts to talk about solutions, concentration, and dilutions. So remember, concentration is basically the amount per volume. And we have a whole bunch of different ways we talked about it, but the biggest one was molarity. Right? Molarity was grams. Ooh, no, it was not. Excuse me. Moles. There we go. Moles solute. It's the pieces divided by liters solution. And we normally will show it with those square brackets. Other things, you had percent by mass. You had percent by volume. We had other things like molality, which we haven't really talked about. But molarity is going to be the biggest one that you need to deal with. Remember, moles over liters. Always moles, always liters to get molarity. Solute, that is what is being dissolved. And solvent is what is doing the dissolving. Water is most often our solvent, but if you think about a solution like a soda, soda is a gas-liquid solution with the gas as our solute and the liquid as our solvent. Kool-Aid is a solid liquid solution where the solid Kool-Aid granules, which are 99% sugar, are our solute, and the water is our solvent. Will all solutes dissolve in all solvents? And the answer to that is absolutely no. And the term should be like dissolves like. So a polar solvent like water will dissolve polar solutes. Okay. When we talk about saturated, when we say saturated, means the solution has as much solute as possible. You can't put any more in. If you put it in, it will not dissolve. So remember, molarity equals moles in mole divided by volume in liters. So that is the formula we need for the next little bit. What is the mass of solute is needed to prepare each of the following solutions? So I need 1 liter of 0.125 m potassium sulfate, K2SO4. The only thing I need is this formula. I need 0.125 m. That's my molarity. How many moles to make a volume of 1 liter? So I'm going to need 0.125 moles because I'm just multiplying 1 by both sides. 375 milliliters of 0.015 m sodium fluoride. So 0.015 m is my molarity, and I want moles. But I have 375 milliliters. That is the same as 0.375 liters. Divide milliliters by 1,000 to get liters. So I know this was a mistake that many of you missed on the practice as well. Make sure this is in liters. So now I'm going to multiply both sides by 375, multiply both sides by 0.375. And so these guys cancel out, and I get 0.01 0.015 times 0.375, I need moles to be 0.0056. Let's see, we can do 3 sig figs, 3 mole. Okay, so now let's look back at my answers. What did I do right and what did I do wrong? I correctly determined the moles, but what was being asked? The mass. So this is another very common mistake. How do I get from moles to mass? You've got to think right back to stoichiometry. If I have moles and I want mass, I'm going to multiply that by the molar mass. So now, K2SO4 potassium sulfate, back to first example, I'm going to need to know its molar mass. Potassium is 39. There's 2 of them. So 39 times 2, 78. Then sulfur, there's only one of those. Sulfur is 32. So now we're up at 110. We've added our 39 plus 39 plus 32. And now we need to add 4 oxygens. So 16, 16, 16, 16. We get a total of 174 grams per mole. Well, we needed 0.25 moles. So how do we get from 0.125 moles to grams? We multiply it by 174 grams per mole. So 0.174 times 174 times 0.125. I need 21.8 grams. There we go. So let's always do that. Let's go back and check. You guys are really good about solving correctly for the first step and then forgetting the second. Same with this one then. So it says still what mass of solute was needed. I used this molarity formula perfectly and I said I need 0.0056 moles and I thought I was done. But now we're going to go back and we're going to look up sodium fluoride. Fluorine is 19, sodium is 23. So 19 plus 23, I have no room, 42 grams per mole. So 42 grams per mole times 0.00563 moles. I need 0.236 grams. I hope that makes sense. So let's look at the next couple of problems. We have grams now in volume and we want to know the molarity. So this is sort of the same thing. I see a lot of people just doing 12.8 and dividing it by volume. And sometimes you remember to convert the volume to liters and sometimes you don't. But first thing we need to do is if we have 12.48 grams of potassium chloride, we need to know how many moles that is. So potassium is 23 according to the periodic table, and chlorine, is 35.5. I never round chlorine, he's in the middle. So I'm going to say that is 58.5 grams per mole. And if I have 12.4 grams, let's divide 12.4 grams divided by 58.5. So 12.4 divided by 58.5 says that I have 0.2, why did I run a 9? 2, 1, 2 mole. So molarity formula, moles, 0.212 mole, divided by volume in liters. Make sure we write liters. I have 289.2 milliliters. I'm going to divide that by 1,000, 0.2892. So 0.212 divided by 0.2892 gives me a molarity of 0.7. Let's see, 4 sig figs and 3 sig figs. So I guess 3 is probably my best bet. Remember, we always put the M after it to indicate molarity. Let's leave you this one. This is going to be exactly solved the same way, but now we have calcium chloride. So, and 0.614 liters. So you try to tell me how many, what's the molarity? All right, so this is a good stopping place. I'm going to stop here. In the next video, we'll go through dilutions. Please make sure you understand solutions and molarity first before moving on. If you need to go back and review stoichiometry, please go back and look at the page 14 videos.